the utility that you would need in order to just enable a community to start, right? So at Fluence, what we're trying to do, we're trying to solve all the water issues or aspect of the utilities associated with any new development. And we're doing it in a decentralized fashion, which you will hopefully understand by the end of this presentation is more efficient and is actually advantageous to the developer. As I mentioned, Fluence, we both are offering water treatment as well as wastewater treatment. So by water treatment, that means that, as I mentioned, you would need to provide potable water to that development. So you would either utilize a local source of water, may that be the ocean. So you would need a small desalination plant, or may it be a local well. So you'll need some sort of a brackish water treatment facility or something along those lines. That's what we call our NairoBox product line, which is shown right here. And then obviously after that water has been used by the residents of the new development, it turns into wastewater, which is when you would need to have some sort of a wastewater treatment system. For this purpose, we're utilizing our Aspire product line, which I will take you through in more detail today. So I want to hope that unlike many other companies in our industry who are mainly focused on municipal applications, and again, when I say municipal application, what I mean by it is that these are applications that are being initiated by a city or by a county or any municipality that essentially fund these projects with public money. And that has a completely different route on how things get done. It typically, it's a much slower process that can take anywhere between, I would say, as little as 2 and as high as 10 years to just take through the entire project. And it's extremely expensive process because it needs to go through a bunch of check and balances along the way that makes the whole process more expensive. What we've done at Fluence, while municipal application are definitely something that we look at. We look at call it the real estate development market with great focus. And this is one of our target markets in North America, the Caribbean, and other places around the world. And the reason I bring this up is because what Fluence had done was to really try and put ourselves in a real estate developer shoes and really understand their needs and come up with solutions, not only product, but solutions that would cater to those needs. So to try to identify some of those needs, that's how we look at it. If you're now needing to build a new development, as I mentioned before, you would need to provide water to that development, and you would need to treat the wastewater. From a real estate developer standpoint, a fundamental part of this is that we don't expect the real estate developers to be water or wastewater professionals. And in other words, what that means is that they need to be comfortable with knowing that the residents in this new development will be able to open their taps and safe water will come out of it, and then flush their toilets, and then the wastewater is gone. That's as much as a real estate developer, from our standpoint, needs to be involved in this process, because really, everyone do their thing, and that's what we come here to do. We come here to make sure that once the toilet gets flushed, we get that wastewater, we treat it, and hopefully we're enabling the reuse of that, which would make the whole facility more efficient. It's not a necessity to reuse it, but it's an advantage that can actually make the economics for many developments look much better. The solution must go through permitting. In other words, while it is true that many new developments are privately done, and that means that they are privately funded, they are still operating within a call it municipal environment, which means that whatever you deploy, you would need to get the local regulatory entity buy on it. So that means both from the local, call it county, city, to be okay with this new development to have its own decentralized utilities, but also from the state which it's located in. So the solution must go through permitting and get accepted. So you as the developer know that you're doing everything right. Okay. Um, it'll be a great advantage for that type of solution to have a modular type of element to it. By modular, what I mean is that any new development would you'd know where you start, right? You know how many excuse me, how many houses you want to build and how many people you're hoping to accommodate in this new development, but you don't truly know how long that's going to take. You don't truly know how things will turn out. In other words, if the amount of houses that you planned for that's if that's truly it's going to happen. And so having a solution that is modular, or in other words, enabled to expand as the development grows, is going to be very advantageous, especially from a cash flow standpoint. So you don't invest money in anything that is not there, right? So let's a development, but you're going to start with only, say, a couple of hundred lots to develop them and then sell them. If you can come up with the treatment facilities to treat only the initial phase and then plan for an expansion for a second phase, a third phase, and so on, your cash management is going to be much more efficient and will enable you as the developer to use that money for other things that are more, for example. So a modular design for the treatment facility is critical. Simple operation. At the end of the day, as I mentioned, nobody expects the developers, or we at Fluence don't expect the developers to become water or wastewater professionals. So any solution that gets deployed in a development must be approachable and operable by the local available operators. That means whether you're in Iowa or in Missouri or in California, um, there's going to be local operating companies that would probably provide their services to operate a plant. And whatever solution gets deployed, operators need to know how to operate it, right? So that means that the solution must be approachable and, as I said, operable by the local companies that exist in your territory. Aesthetics goes a long way. Obviously, when you develop new neighborhood, you want to sell the lots. Selling the lot means that it's got to look good. The development needs to look good, and nobody wants to see a disgusting or a bed, an eyesore as they call it, in the middle of their development, right? So that means that the solution must be aesthetically nice, okay, from an eye perspective. It should not produce bad odors. Again, remember, we're dealing with wastewater treatment here, and it should not create loud noises, right? So we take all these things into consideration, or we at least acknowledge that developers have that need in their new development. Last and definitely, but not least, beyond just the equipment part of the solution, there's the commercial part of the solution. And as I mentioned before, you gotta, as a development, probably manage your cash in the best way. And so any company that would bring the solution, but would be able to accommodate different commercial approaches, whether it's a lease to own, what we call the BOO, build, own, operate. Any type of those commercial approaches will be advantageous to the developer, right? So that's why the solution must be also, as I call it, commercially flexible. That is how we look at the need from a real estate developer shoes. So at Fluence, as you could all understand, we have multiple type of solutions and product lines and so on. The product line that, as you can see here, the product line that we're going to focus for the rest of the presentation is what we call our Spiral Flex system. I'm going to focus today on the wastewater treatment part of it. As I mentioned before, we also provide water solutions, but I wanted to focus on one because it's pretty much similar to the water side of things. And that's why I decided to just go with our package wastewater treatment solution, which is called Aspirate. So what we have done, we've developed this product line that is built out of building blocks. And basically we call it the building block approach. I'm a big Lego fan. I always played Lego as a kid. And I really, just like many other kids, enjoyed the flexibility Lego blocks would have, right? You could make Lego, you could build different blocks with Legos that would have different functions. We basically try to do the same thing with the wastewater treatment plant. Instead of your conventional, Lego brick that hopefully some of you are familiar with, we used a marine shipping container as the standard Lego brick, if you would. When I say marine shipping containers, it's not like we're taking used shipping containers and refurbish them and then modify them to what you're seeing on the screen. We build tanks from scratch, but we design them in the same size and dimensions as marine shipping containers, and we actually certify them as such. What that does, it helps us standardize all of our solutions. And so that means that from our standpoint, engineering and assembly, efforts get reduced quite significantly, okay? Because you're always operating within the same volume, that same 40 by 8 building block, okay? Secondly, what it does, a marine shipping container is a very standard piece of equipment, if you would, which any local general contractor, any local technical entity, if you would be familiar with it, and it will be very easy to explain it to people outside of Fluence, if you would, how to manage it. Basically, you're telling them, look, you're just moving marine shipping containers around. So that reduces the amount of uncertainty those additional service providers would have and reduce the overall project cost. Let alone that from a shipping standpoint, it is significantly cheaper to transport conventional shipping containers as opposed to tanks that are not really standard. Okay. And so the takeaway from this slide is that our fundamental building block is a marine shipping container. As I mentioned before, these are not refurbished ones. We build these from scratch, but this is our fundamental building block. And then the internal of these shipping container is what differentiate from one building block to another. And as you can see here, we have multiple different types of building blocks. Once we put them together, you get the complete treatment system based on your specific drivers as a specific development, whether it's the size of the development in terms of how much flow, how much wastewater will need to get treated, whether it's the type of wastewater coming in. In other words, if now the development is more hotel type of development, it's going to have one type of wastewater. If it's a residential type of development, it's going to have a little different characteristics for the wastewater. Or if it's more of a commercial development, which will have, call it third type of wastewater coming in, and also what type of treated wastewater, or as we call it, effluent, you're going to have out. So having these different building blocks as our tools at Fluence, we are able to put them together and customize a solution for different applications, but without going through the whole effort of designing everything from scratch. We have those existing building blocks. It's all a matter of just putting them together. And I'll try to give a couple of examples along my presentation. So let's use one example for a residential development. Okay, let's say that there is a new development. which is going to be phased into two phases. The first phase, we're going to look at building 335 lots, which is going to have a couple of residential units on them. And let's assume that every residential unit would produce approximately 150 gallons per unit per day. And so when I multiply 335 by 150 gallons, I get to approximately 50,000 gallons per day worth of wastewater that needs to get treated. That's how we would look at it. So we would talk to the developer. We'll try to understand how many lots they would like to start with, convert that to how much wastewater that is that we need to treat. We can assume what comes in. You guys don't need, whoever is not very technical, you don't need to understand to really understand what BOD means, what TSS means, or what TKN. These are correct elements that help us to understand how much pollutants exist in the wastewater and how much of it needs to get removed. Okay. And so that's what's going to come in influent, and what's going to come out. These are assumed. These are going to be dictated by the excuse me, by the local regulator, and also by what you want to do with the treated water, right? So some developers would like to reuse it for irrigation of the plants around the development. Other would like to just get rid of it to the environment. Whatever you decide to do with the treated effluent is going to change the type of effluent you'll need to get to. Okay, so here we're assuming these numbers right here. Again, I don't want to get into what each one means. Excuse me. And then let's assume that later on, as the development grows, you would like to add approximately 665 units to the development on top of the initial 335 units, which translates to additional 100,000 gallons per day. So your overall development would be 100 plus 50, which comes out to be 150,000 gallons per day, or approximately 1,000 units, 1,000 residential units on the property. I intentionally use the 1,000 number in order to try and work with even numbers and make things a little more intuitive. Okay, so once we understand that, we understand how it would make sense to break out the growth of the development, we would start putting our building blocks together. Okay, and so for the first phase, we would say, okay, for the initial 50,000 or 335 units, we would need what they call one equalization tank, one of our spiral L3 biological reactors, one of our ultrafiltration containers, and one sludge holding tank. Just very briefly on each one of these building blocks. Each one of these building blocks is its own treatment unit, but treats a different contaminant in the wastewater, if you would. So for example, the equalization tank, excuse me, I'm a little under the weather. That's why my voice is a little deeper than usual, so I apologize. The equalization tank is a component that is meant to buffer the peak flows that development gets, right? So when you build a residential housing, most people take showers in the morning and in the evening. So that means that a lot of water is going to come into the wastewater treatment plant during the morning and during the evening. But it does not make sense to design a full-blown treatment facility for those peak flows. So what we do, we put what we call a dump tank or a buffer tank that would know how to take those peak flows in the morning and in the evening, just accumulate the water, but then make sure that an even flow goes to the actual treatment facility 24 hours a day, 7 days a week, right? So instead of designing for a big, large treatment facility that knows how to accept those peak flows, we put a buffer tank in order to mitigate those flows and just treat the wastewater evenly 24 hours a day, 7 days a week. Following the equalization tank, we will have our biological reactor, which we call it a spiral L unit, which basically takes the soluble pollutants in the wastewater, expedites the growth of bacteria that takes those soluble pollutants, digests it, and basically cleans the water and convert it into a bacteria, which would get removed in the ultrafiltration phase. Okay, whatever is left gonna go to the sludge holding tank, and pretty much this completes your entire solution for the first 50,000 gallons per day or 335 units. Then, as we said, second phase of the project will come through, and basically additional 665 units will get built, which will call for the need for 2 additional equalization tanks, 2 additional biological reactor tanks or spiral L3 tanks, and 2 UF cassettes. So this is not an additional container unit. It's just an additional elements that would go into the initial unit that was deployed. Okay? And in short, what it does, it means that obviously you did not need to pay for all these elements in the initial phase, right? In the initial phase, only what was needed was provided, but then at the later stage, additional components were delivered to basically come up with a complete solution. But as you can see, and I really try to simplify this for you. The next slide shows how engineers would receive this layout, but what I'm trying to show is that these are truly like Lego blocks that you would add on, and that it's as simple as that, right? So at the end of the day, to treat a facility of about 150,000 gallons per day or 1,000 little houses, you're looking at about this a footprint of about only 6,000 square foot, give or take, of course. Okay. In reality, the engineer that we will work on will receive these type of documents, which really lays everything out, shows how the piping goes, show the type of pipings that comes with it. I bring this slide in order to show that once we basically develop all of this product line around these building blocks, this enabled us to produce documents extremely fast that basically say, okay, you now need, dear developer, you want to treat only 335 houses now. This is how many units you would need. One, 2, 3, and then sludge holding tank, 4 of those units. We generate this drawing that you see in front of you in a matter of, if you would, like minutes. We generate the bill of materials that is associated with the installation of these units, and that type of document can be sent to a local general contractor, and they read these type of documents all day long. So for them, to understand this, if you would, shopping list right here, they can give you a price estimate of what it would cost to deploy these units, also in a matter of a couple of hours. Okay, so everything gets streamlined, right? Because again, all the product line is centralized around these building blocks. It's very easy for us to generate these automatic documents or tools that produce these documents very quickly to pass on to a local general contractor or an engineer to review and get back to you with some good numbers or budgetary numbers to go with. Okay, that's why the title of this presentation is Streamlining these utilities geared towards real estate developers. Okay, so this is one type of document that we're able to generate very quickly, and then your engineer or your general contractors can take that and give you what we call a turnkey budgetary estimate on what you're looking at, and it's going to be pretty accurate. Okay, another type of document that we would produce would be what we call a 20-year life cycle cost analysis. So any solution that we come up with, we can then follow up with what we call a 20-year life cycle cost analysis, which basically says, okay, for the next 20 years, operating this facility will cost you this much. And I know this is small. I couldn't squeeze it large enough in order to show it. But basically what this shows is the parts that you will need to replace over the next 20 years for the treatment plant and the cost associated with it. It shows the cost associated with operating the facility, so what we call labor cost or your local operator, because we know how many, excuse me, how frequent we need the local operator to come and operate the facility and attend it. The cells highlighted in yellow are cells that are plug-in numbers. So we assume a labor rate of an operator in this example for $50 an hour. If you know that you're situated in a place that either is more expensive or cheaper in terms of labor cost, you can just tweak those numbers and you get a 20-year estimate on how much you're going to be spending for the next 20 years, but it also give you the annual spent, right? So you can also understand how much you're going to be spending annually, because we understand that many developers are not planning to invest and develop a property and then operate it for the next 20 years. Many of them will just stick around for the first, call it 2, 3, or 5 years and then flip it, right? So this gives you the estimated cost associated with operating these facilities on an annual basis, but then on a 20-year life cycle cost, which you can then pass on to whoever is going to be buying this development. Okay. So as I mentioned, you're looking at the parts that are going to be need to be replaced over time, about the labor associated with operating the facility, about the chemical consumption, because there are some chemicals that need to be added to the treatment facility, again, depending on, where you are, what you need to do, and so on. So that is also there. The estimated, excuse me, power consumption for the facility, because obviously, these are mechanical systems, so they need to be connected to some sort of a power source. So we can give you the estimation of how much power is going to be consumed for operating the facility, again, on an annual basis and a 20-year basis. And then, of course, as I mentioned before, when you treat wastewater, what you treat, you're left with clean water, but what you got out of the dirty water is still there. That's what we call sludge. And that sludge, typically for smaller developers, it gets hauled away to a larger facility, but that is cost associated with it. So we're including those costs as well. And so the bottom line, or what I'd like you guys to take away from this, is that this is another document that we're producing very quickly, but that gives you more information on what you're up against and how much you're going to be spending, not only for buying equipment, but also operating it. Okay. And again, all of this gets streamlined. We at Fluence, we produce these documents extremely quickly, again, because of the nature of this product line, that it's all pre-designed, pre-engineered, and ready to go. So we know exactly what it means, each element that we add to it. And because of that, basically, this enabled Fluence to come in and say, you know what, here we can offer the equipment, we can support you with the installation, we can support you with the operation of the system, and basically take all this burden away from you, and we'll come in and take over. And that kind of leads me to the last point, that basically that's what I showed in the slide, where we said that we needed to be, that we felt that developers need someone that will be commercially flexible, as I mentioned. And that's why we basically not only developed the product that I just showed you, but we've developed a whole scheme of commercial approaches that we can work with the developers. So anywhere from a lease to own, if you would, for short terms, as little as 2, 3, 5 years, I would say. You can see these are just some examples where we would work with the local developer. We would lease them the equipment and basically help them own it during the time frame. We can also do just a straight lease, right? Obviously, these things will impact the monthly fee and whatnot, but the bottom line is that we are geared up to provide, as I said, a lease to own, like you would have in other lease to own instances on cars, for example, a straight lease, or basically a complete turnkey sell, which we would say, okay, here is the equipment, here is the installation associated with it, here is the engineering piece of it. So we would work with local engineers and permitting agencies to make sure everything gets permitted and try to develop this package that would hopefully take a lot of the heavy lifting away from you, the developer, which will enable you to focus on other very important things that are associated with this development, while you can rest assured that you're being taken care of from the wastewater treatment side or the water treatment side. On top of that, we would work to provide you annual services, if you would. So, as needed, technical phone support. We really try to cover everything in order to make sure that you feel comfortable and that your risk is minimal when it comes to the water treatment and wastewater treatment. Um, I did talk briefly about how it's important for the solution not to be an eyesore, how it's important for the solution not to generate odors, not to generate noise. These are just examples of different solutions that we work. They're not necessarily what we do. In other words, Fluence does not provide shelters for wastewater treatment plants, right? Or we don't necessarily provide the 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 painting on the wastewater treatment plant, but we are familiar with it. We have worked with different vendors to try and satisfy the client needs. And my point is, we're not this type of company that tells you, okay, here's our product. Now you want to make it look nicer. Okay, good luck with that. No, we will work with you. We will try to offer some ideas that can work or that we've done before. That's why I'm showing some examples. You may like this one more, you may like this one less, but the bottom line is that we are familiar with it and we can accommodate different needs based on your drivers or your community and so on. So I think this is a good summary slide for the value proposition that the Spiral Flex or the Spiral product line brings with it. Okay, so this is kind of a quick summary to what I've talked so far. Basically, we feel the modular approach, which enables you to build as you grow. So you only install the treatment capacity that you need right now, and then as you expand, you buy more equipment and you treat it there. That helps you to um, basically control your cash better. The fact that we have those different units or building blocks with different functions enable us to meet different objectives depending on the application and drivers. So it's not like we're bound to one type of treatment. We can pretty much accommodate different treatments based on what you need. So that means that we don't necessarily need to shove a treatment down your throat, even if you don't need it, just because that's the only thing that we can offer. We can offer multiple type of treatment systems, if you would. As I mentioned, cash flow positive. That's kind of what we're trying to keep you as a developer. So you only, as we said, are able to accommodate the different commercial approaches, and of course, the build as you grow approach. And then obviously the containerized structure really enables us to do this whole thing the way we're doing it, right? Because the certainty of the cost that we're going to see is very high. And that's why this certainty translates to very flexible terms for you as the end user. As I mentioned, these are pre-engineered solutions, which means that they are factory tested. Once we finish manufacture them, we deliver them to the site, but there is very minimal work at the site. This is big because nobody likes to see a bunch of people on their site for long duration of times. You want them to come in, put the units in, pump it up, pipe it all up, and get it going. You don't want, solutions that would cause very long installation periods and many people going in and out the site. We understand these are residential places that you don't want to see construction workers all day long. Um, and and so that's part of the advantage of this being a pre-engineered solution. Inclusive design, I apologize, this got cut in my presentation, but basically what this comes to say is that we take care of everything, all of the different elements that are associated with the wastewater treatment. So essentially, the only thing that we need is the wastewater to get delivered to the treatment system. So we don't do the collection system for that matter. And then we then generate the treated water to go out of the system, which you take from there, right? So basically, we take everything within that block, if you would. And then all of our, call it commercial options or a la carte options, which is the capital purchase, lease to own, service contract, operations contract, installation packages, complete design build, we can accommodate all of that. We have no interest for one approach over another. We just really want them or you to choose whatever makes more sense to you. Some developers, they like to do the heavy lifting. They like to hire the engineer. They like to take the system through permitting. They like to do the installation. Other developers say, guys, I want a one-stop shop. You take everything for me. And so we can accommodate both options or all options in between as well. I will finish with a real life case study. This is a mobile home park, or sorry, an RV resort. If the client would hear me calling this a mobile home park, they'll be upset with me. This is a high-end RV resort in La Pine, Oregon, which had an 18,000 gallon per day average flow with 42,000 gallons per day peak flows. I don't remember off the top of my heart how many houses is, how many homes that includes or RVs that includes, but you can see that the map here, probably a few tens of little RVs spots in that facility. Um, so the developer basically spoke with us. We worked with them to see, okay, what would make the most sense. Again, I'm not focusing on the technicalities of this application. What I do want to show is that multiple other companies and technologies have been evaluated during the process. So each one of these bullet points is a different type of technology or company um, that could provide similar solutions. But when the developer basically took into consideration the overall capital cost, the overall operating costs of the system, the overall repair and replacement cost summary, the spiral solution came up on top, and that's why they ended up using us. Again, I can share this presentation with everyone, and it will be available online, I believe. Jessica will confirm. But the takeaway from this is that it's not because we are offering these nice modular solution or we're being very flexible on the commercial approaches. Because of that, we charge you premium. That's not the case. We are still very competitive versus other technologies or other manufacturers. So it's not like we are saying, oh, we're so modular, we can charge premium on that. No, we charge because, again, remember, we also participate in municipal jobs or publicly funded jobs. So we need to know how to address those jobs. And there is some carryover to whatever we do here on the private side or on the development side, right? So my point is that we are still very competitive when it comes to pure capital comparisons, operating cost comparisons, and overall comparisons. I think that's me. I wanted to allow sometimes to questions if there are any. So thank you everyone for taking the time and listening in and joining us today. And yeah, Jessica, let me know if any questions were
Yeah.
raised during the presentation.
Yeah, thanks, Ronen. It does look like we had a few questions come in through the chat, so I can read them off to you and you can answer them. And then to everyone else, if you do have questions, feel free to add them to the chat and I will try to get through all of them. The first question we have, Ronen, is what percent solids out of the sludge tank digester, and does it meet any volatile solids reduction and vector reduction?
I'm sorry. Can you repeat that one? I lost you at somewhere. Can you see my screen? I'm reading the question as well. What percent solid out of the
Yep.
sludge tank digester, and does it meet any volatile solid reduction and vector? Okay, so what we provide is what you call a sludge holding tank, okay, with a decanting option. What that means is that the WAS, this is a technical question, so I apologize if I'm saying some words which may sound like cuss words to you all. But basically, what we're providing is this sludge holding tank right here, and I have a data sheet that shows it. Perhaps I can pull it up on the screen real quick. Um, but long story short, what we're doing, it's a sludge holding tank that has a capacity of anywhere between 7,500 gallons to 17,000 gallons. Okay. The WAS, waste activated sludge, coming out of our process is approximately 2% of the daily average flow. Here we go. I think I'm going to pull up the data sheet for the sludge holding tank right here. Okay. Can you guys still see my screen? Jessica, I'm deferring this
Yep.
question to you. Okay.
Yep. It looks great.
Okay. So basically what that means is coming out of our process, as I mentioned, you're going to have some waste, right? What we refer to as waste activated sludge, or in short, WAS. That was comes out at approximately 2% of the daily average flow. So if you had about 100,000 gallons per day worth of wastewater to be treated, about 2% of that translates to 2,000 gallons a day worth of sewage that will need to be accumulated in this sludge holding tank. But as you can see right here on, can you see my cursor on the right hand, on the bottom side that I'm circling?
Yep.
What happens here, these flanges gets connected back into the equalization tank, because in this tank, the sludge out of our process has very good settling properties. And essentially, after about 40 minutes, about most of the heavy solids would settle down. And then you'll have an upper phase of water, or what we call supernatant, which will then get pumped or just gravity flows back into the EQ tank, essentially reducing your sludge content for evacuation to about 1%. So realistically speaking, we're talking about if you had a 100,000 gallons per day treatment application, you'd be left with about 1% of that as sludge that you'll need to evacuate off site. So that would be about 1,000 gallons a day with a solid concentration of about 2%. I hope that answers the question.
Great.
Should we
Thanks,
go?
Ronan.
Should I go? Yeah.
Yeah, we have quite a few over on the side.
Okay, so I'm just going to read that out loud. Can you speak to typical lead times for a system to be delivered in the Southeast USA as presented? So our typical lead times, we're talking approximately 6 months. Sometimes it can go a little quicker. Sometimes it can be a little slower because we are still bound to shipping, I would say, to the shipping world, if you would, right? So sometimes there are no issues. Sometimes we do see some delays. 6 months is a good estimate to take into consideration. I will say that sometimes we do have some available units, right? So that can be even quicker. I don't want to say immediate, but definitely quicker. But to give a simple answer to a simple question, I would answer 6 months as a lead time for the units to be delivered to the job site.
The next question is, do you have any installations in the Arctic or subarctic?
So Fluence have of these. So Fluence has multiple product lines, right? So the simple answer is yes, but the non so simple answer is that for this product line, the spiral product line, we have approximately 400 installations globally, Many of them are in cold environments, such as North Asia, the northern part of Asia, which gets extremely cold. Here in the US, we have a couple of installations in Oregon, as you saw, in Iowa, in Indiana, places that do get cold. Subarctic, like Alaska and stuff, we don't have those type of installations quite yet. Nonetheless, um, from an installation standpoint, they do things very straightforward in those areas, which means they basically build structures around the treatment units. And so that is a structure that gets built around it. We can work with you on sizing the structure, but what our experience shows us that many times when you operate in those extreme environments, they're already pretty set ways to go about how you install things that can be that it's problematic for that equipment to be exposed to the elements, right? And so we will just accommodate whatever is customary locally, and work with the local, I would say, agency to provide whatever is needed for the complete solution, if that makes sense.
Great. Okay. Next we have for wastewater treatment, do you actually offer an MBR configuration? What membranes are you using, pore size, and membrane configuration? And is permeate generated using a vacuum pump?
Okay, so first of all, we call it ultrafiltration because we try to separate the biological part from the solid liquid separation part, but essentially we are offering an MBR. Okay, the membranes that we use are from Manhummel, what used to be Microdyne Nadir. This is a type of a flat sheet membrane that we've been using. We have a great collaboration with Manhummel. We've been working for many years with them and are extremely happy with the performance, the service that we get with them, and the support. They're well recognized globally and obviously in North America. So that's who we used integrated into our package plant, if you would. I will say that we don't offer only MBR. We also offer containerized clarifiers and other means for liquid solid separation. Manhummel, now I don't remember off the top of my head about the pore size. I can definitely, if you would send me that request, you saw my email and I will type it here in the chat as well. Our Bark, so you can follow up with questions as well. Here you go. I just typed that for everyone's sake. But what I was going to say is that I don't remember the pore size. It is a type of membrane that we have a bidirectional pump that backwashes it when it needs to, but then also pushes it, pumps it or pushes the effluent out as well. But I can provide all of the specifics for the UF membrane as needed. Okay. Um, I will skip to the next question that you had asked. That's about the installation in colder climates if we insulate the containers. So we do, but insulation, excuse me, and I will bring that up. What we prefer to do is basically either trace heat the pipes, the external pipes that are associated with the solution, because as you saw, there are some external piping that takes place. So we would trace heat the external pipes, but then we will either put a structure around it. We do have applications such as in Albuquerque, New Mexico, which is considered a high desert, and it can get pretty cold over there, where we have insulate the container itself. In other words, we put, I believe, a 2-inch fiberglass plates around the unit and then skinned it with wooden frame. So yes, the answer is yes. There are multiple ways to go about it. We really work with you to kind of explain what is best under your circumstances. So for example, in Iowa, which also gets very cold, we just put a shed around the whole unit, right? So it really depends on the specific application. Um, Trying to go back to here we go. Oops, sorry. Okay, next question. Excuse
Yep.
me.
The last
Here.
question is, for countries with power access issues, what are some options for power?
So, first of all, great question. One thing that I did not talk about is the fact that within our systems, we are enabling Fluence's proprietary MABR technology. MABR technology is a component that goes into the biological part of the process, represented by these green circles on your screen. And it essentially reduces the energy consumption associated with aeration, which is the biggest energy consumer in any type of biological treatment. It reduces that energy consumption by over 90% compared to conventional aeration systems, such as fine bubble diffusers. That is huge. And so that means that in places where either power is scarce or it's very expensive, we would deploy the MABR technology in order to reduce the overall cost, the overall energy consumption associated with the treatment facility. On top of that, as I mentioned just a couple of minutes ago, we can deploy a UF membrane, or as the liquid solid separation mechanism, which is a more intense treatment, but then again, it consumes more energy. Or we can deploy what we call a secondary clarifier as the mean for the solid liquid separation, which basically means that the energy consumption associated with that type of approach is significantly lower. And so once we know that we operate in a place where energy is either expensive or there's not a lot of it, we would tailor the solution that will be the most energy efficient. And on top of that, we can work with you to either see if some of it can be accommodated by solar. We're working with a couple of clients right now, actually, that are planning to deploy solar panels around our system and to try and operate it on that means only, or just have a standby diesel generator to accommodate the need to accommodate the energy as needed. I And the last one, I see that certificate of attendance showing credit hours that can go through you, right, Jessica?
Yep, I just responded to that one.
I saw. Okay, so I think that is my hour. Am I right? Am I wrong? Was I just on
Yeah,
time? I'm very proud.
yes. Great
So
job.
yeah, so thank you everyone again. Really appreciate your time. Really appreciate the great questions. You have my email in the chat box. I'm available for any additional information you may need. And thanks again for attending. Have a great rest of your day and great rest of the week.
Thank
Bye-bye.
you.